In this video, we'll cover the first two chapters of the textbook, including an introduction to statistics and an introduction to sampling. We'll talk about the different types of variables and the roles they play. We'll talk about how to summarize the different types of variables. We'll talk about the four processes of statistics. And we'll talk about how to produce data through sampling. So, what is statistics about? Let's look at a couple of examples. Let's say that I have a large collection of articles and reports of a statistical nature. How would we classify them? To make it more personal for you, let's say that you have a collection of exam problems at the end of the semester. How will you pick the right procedure to solve those? The answer to both of these questions is that statistics is all about variables. Statistical variables may be categorized as either categorical or quantitative. We'll talk about the definitions of those later. We may also consider a single variable or a relationship between two variables. Identifying whether a variable is categorical or quantitative, and whether we're considering a single variable or a relationship between variables, is critical when it comes to choosing what techniques we want to use to solve problems at hand. When we're looking at relationships between two variables, we'll think of one as explanatory and the other as response. Generally, we'll think about the explanatory variable as the x variable and the response variable as the y variable. Depending on what types of variables we're considering and the roles they're playing, explanatory versus response, we will have 5 situations. We may look at a single categorical variable, a single quantitative variable, one categorical and one quantitative variable, where the categorical variable is explanatory and the quantitative variable is response. We may have 2 categorical variables, one as the explanatory and one as the response. And we may have 2 quantitative variables, one as explanatory, the other as response. You may notice that we don't have a categorical and quantitative variable where the quantitative variable is explanatory and the categorical is response. When we're faced with a situation like that, most often we will rephrase it so that we're actually looking at 2 categorical variables. Let's start by looking at an example of the different types of variables. Remember, the types of variables we will consider are categorical and quantitative. A categorical variable is one in which each member of the population is assigned to a category. A quantitative variable is one in which each member of the population is assigned a number. Consider these headlines. Dark chocolate might reduce blood pressure. Half of moms unaware of children having sex. Vampire bat saliva researched for stroke. What types of variables does each article involve? Well, the first article would seem to indicate that if a person eats dark chocolate, their blood pressure might drop. Whether a person eats dark chocolate or not is a category. One's blood pressure is measured with a number, so dark chocolate or not is a categorical variable, blood pressure is a quantitative variable. Whether a mother is aware of her children having sex is categorical. One category is aware, the other category is not aware. Vampire bat saliva or not is categorical. Stroke recovery is probably also categorical, unless there's some sort of numerical measure that they are looking at for whether a person recovered from stroke. We may sometimes switch between categorical and quantitative. Let's look at an example. Individual teenagers were surveyed about drug use. They are asked whether they have used marijuana and whether they have used harder drugs. What types of variables are we looking at here? Whether or not a teenager uses marijuana is categorical. It's yes or no. Similarly, whether or not a teenager had used harder drugs is also categorical. Again, yes or no. Let's look at a similar question, but looked at in a slightly different way. In this case, we're looking at percentages of teenagers that have used marijuana or hard drugs for a sample of countries. Now here are data points, the individuals in the population. Instead of being individual teenagers, we're looking at individual countries. And for each country, what is being reported is the percentage of teenagers using that drug. So the percent of teenagers using marijuana in each country is quantitative. That's reported numerically. The percent of teenagers using harder drugs is quantitative. Here's another way that we can look at the same set of data. We could treat this as a relationship between a categorical variable, the type of drug, and the percent of teenagers using each of those drugs. As you can see, different situations can be looked at in different ways. The way that we want to look at it will affect the way that we will treat it when we're trying to solve problems. We can also turn quantitative variables into categorical variables. For example, researchers studied effects of dental x-rays during pregnancy. The way they did this was to look and see whether the mother was exposed to dental x-rays and then measured her baby's weight. Another approach is to check and see if the mother was exposed to the x-rays and then classify the baby's weight as normal or subnormal. What types of variables are we looking at here? Well, in the first approach, whether the mother was exposed to the x-rays is categorical. The baby's weight is reported as a number, so that's quantitative. In the second approach, we have the same categorical variable for the explanatory variable, but now the response variable, the weight, is classified as normal or subnormal. That's now categorical. Let's look at a few definitions. Data is a set of recorded values of variables. Statistics is the science that's concerned with gathering data about a group of individuals, displaying and summarizing the data, and then using info from that data to draw conclusions about a larger group. Once we have the data, let's talk about how we can summarize it so that people can easily digest what you have learned. For categorical data, there are three ways we will summarize. With the count, simply reporting the number of individuals in each category. With a proportion, which is the count in each category divided by the total number of individuals considered. And as a percentage, which is simply the proportion multiplied by 100%. For quantitative data, we will most frequently use the mean to summarize. You may have heard mean called the average in the past. Since average is sort of a loosely defined term, we'll prefer the term mean. We compute the mean by adding up all the values and dividing by the total number of values considered. Let's look at another example of summarizing variables. 1.9% of students nationwide got special accommodations for SAT. At 20 prominent Northeastern private schools, nearly 1 in 10 received special treatment. What type of variable are we dealing with here, and how is the summary reported? Here, whether or not a student received special accommodation is categorical. It's summarized both as a percentage for the nationwide and as a proportion for those in the private schools. When you're trying to decide how best to summarize a variable, it's important for you to recognize what the individuals in the population are and what data is being recorded for each. Let's look at another example of summarizing variables. On average, a white man with a college diploma earned $65,000 in 2001. Similarly educated white women made 40% less. Black and Hispanic men earned 30% less. What type of variable is being considered for each demographic group, and how is it summarized? Here, we're really looking at a relationship between two variables. The explanatory variable is the demographic variable. The response variable is the earnings. Earnings is a quantitative variable, and it's reported as a mean. We have three different demographic groups, but only one mean is being reported. That's the $65,000 for white men. When we're looking at several different groups, we'll sometimes see reported a percentage above or below a reference value. In this case, the reference value is $65,000. Now let's consider relationships between two variables. Recall that one of the two variables in a relationship is termed explanatory. The other is called response. The response variable is a variable whose value is affected by the corresponding value of the explanatory variable. We tend to think of these as not necessarily a cause and effect, but we're looking for a possibility of a cause and effect relationship between the variables. When we're looking at these relationships, there are three situations that we'll consider. Let's look at a couple of examples of relationships between variables. We'll take some time to identify the types of variables involved and the role of each. Let's look at a couple of headlines. Men twice as likely as women to be hit by lightning. Do Oscar winners live longer than less successful peers? What types of variables are we looking at here, and what are the roles that they are playing? In the first situation, the headline claims that a person's gender affects their likelihood to be hit by lightning. So what we're looking at here is a categorical explanatory variable, gender, and a categorical response variable, being hit by lightning or not. Look at the second one. Do Oscar winners live longer than less successful peers? Here, the claim is that perhaps if an actor wins an Oscar, then they will live longer. So the explanatory variable is categorical, and the response variable is quantitative. It's measured in years. Let's consider some more examples. Headlines. 35% of returning troops seek mental health aid. Smaller, hungrier mice. Counties average weekly wages at $811, better than U.S. average. What types of variables are involved here? If there's a relationship between two variables, what roles do each variable play? In the first situation, we're looking at returning troops. That's our population. And we're considering whether or not they seek mental health aid. That's categorical. Notice that it's being reported or summarized as a percentage. That's what we expect for categorical variables. For the mice, size is quantitative and explanatory. We would measure that in something small, ounces, grams, depending on which system of measurement you're using. And appetite is also quantitative and the response. In the last one, county's average weekly wages at $811, better than US average. I'm looking at these terms average, and I'm thinking this is probably quantitative, and it is. In fact, the summary of the mean is being reported. That's a quantitative variable. Now let's consider a few more definitions. A random occurrence is one that happens by chance alone and not according to a preference or an attempted influence. It's that attempted influence that can really be tricky. We'll talk more about that as we get to it. Probability is the formal study of the chance of something occurring in a random situation. Statistical inference is the practice by which we draw conclusions about a population based on data we collect from a sample. These latter two bullet points are linked together through the four-stage process of statistics. Let's talk about these statistical processes. The first is data production. Data production is the process by which we design our survey or experiment, collect our data, hopefully using a study design that avoids bias. The second process is displaying and summarizing. Here, depending on the variables and the relation, or whether there's a relationship between variables, we choose the appropriate way to summarize and display. The third process, probability, describes this situation. Assuming we know what's going on in the population, what will a random sample look like? That question is governed by the science of probability. Inference is in many ways the opposite of the third process. Inference is the situation we find ourselves in when we don't know the behavior of the population, but we do have the behavior in a sample. Statistical inference is the process by which we use sample data to make inferences, guesses, about the population. Let's talk about data production. There are two critical parts. First is choosing a good sample design. Without a good sample design, so that our sample is unbiased, any generalizations we make about the population will be suspect. In addition to the sample design, we want to make sure that we also have a good study design. The study design will make sure that our summary of what's going on in our sample is unbiased. Let's talk about what makes a sample design a good one. First, some definitions. The first is bias. Bias is the tendency of an estimate to deviate in one direction from a true value. There are lots of different kinds of bias, so let's talk about those. The first kind of bias we may run into is called selection bias. Selection bias occurs because we have an unrepresentative sample for some reason. The study design might be good, but the sample design is not. Among the sources of selection bias are the fact that the sampling frame may not match the population. For example, if you want to learn something about the student population at Wofford, but all of the students in your sample are athletes, it would be hard to make a good generalization about the student population as a whole from that sample, because the sample frame, in other words, the group that we're pulling our sample from, doesn't look like the population as a whole. We could look at a self-selected sample or a volunteer sample. In this case, we worry about people who are willing to volunteer having different values for their variables than those who don't. For example, if you're looking at reviews of a product on an online store, many times they tend to be good or bad, but very few in the middle. Those samples are volunteer samples, and people who have strong opinions one way or the other are more likely to volunteer. We could have a haphazard sample. A haphazard sample is a sample like instead of choosing people at random, we choose people off the top of our heads, let's say. So it feels random, but in a sense it's somehow governed by the fact that human beings are very bad at randomizing. We'll look at an example of that soon. We could also have a convenience sample. A sample of convenience is one like if, again, we're trying to find out something about the Wofford student population as a whole, and in order to collect data from our sample, we simply go stand outside of Burwell during the lunch hour and ask people our survey questions as they walk by. For written surveys, non-response can also be a problem. If, let's say, we mail off a survey to a bunch of people chosen randomly, some people are not going to fill it out and return it. If there is any difference between those who do respond and those who don't respond, we'll be exposing ourselves to non-response bias. Let's look at some examples. A professor wants opinions about a textbook. Of the 80 people in a class, the professor wants 6 respondents. One way he could go about doing it is to have students raise their hand if they'd like to volunteer. The professor could simply sample the next 6 students that come to visit office hours, or he could simply pick 6 names off the top of his head. For these methods of sampling, should we worry about bias? Well, for each of them, I think the answer is yes. The first one, that's a volunteer sample. Again, people with strong positive or negative opinions are more likely to volunteer. In the second one, that's a sample of convenience. Here, the professor is only asking the first 6 students that he happens to come across. But if those are the 6 students coming to office hours, maybe the reason why they're coming to office hours is they don't think the book is good and they want additional help. That sample would not be representative of the population as a whole. The third situation is a haphazard sample. Picking 6 names off the top of his head would result possibly in a biased sample, in that perhaps the professor is thinking of those 6 students because they're the ones who come to office hours most often. Thinking about the same situation, let's look at some other ways of collecting sample data. The professor could assign each student in the classroom a number, 1, 2, 3, etc., and then use some sort of random number generator to select 6 at random. Second, the professor could take a random sample from the roster of students enrolled and mail them an anonymous questionnaire. Should we worry about bias in these 2 situations? Well, that first one looks pretty good, but I am worried about bias there. The problem here is that we're assigning each student in the classroom a number and choosing from among those. That means people who are not in the classroom, those who are skipping class, are not represented. That results in a different sampling frame. In the second situation, mailing anonymous questionnaires introduces the possibility of non-response bias. Let's go over a few definitions when it comes to sampling. A probability sampling plan is a plan by which a sample is chosen using randomness. A simple random sample is a sample that is taken at random and without replacement. That means that each person could only be selected once in our sample. A stratified random sample takes separate random samples from groups of similar individuals. Those are the strata in the stratified random sample within the population. For example, if we are taking a survey of Wofford students, we want to make sure possibly that each class, first year, sophomore, junior, senior, is equally represented in the sample. So a stratified random sample in this case might take a simple random sample from among the seniors, then a separate simple random sample from among the juniors, and so on. A cluster sample is a sample in which small groups, those are the clusters, are chosen at random from the population, and then every member of the clusters are included in the sample. An example of this might be if we're looking at a sample of Wofford students. 8 classes, individual courses, are chosen at random, and then every student enrolled in those randomly selected courses would be given the survey. A multi-stage sample is one that you frequently see in online surveys. In this case, general broad questions for sorting respondents into categories are given first, and then random samples are taken from among those that are in the category that we're interested in. Finally, a systematic sampling plan uses something non-random but methodical. An example of this might be listing all Wofford students in alphabetical order by last name, and then choosing every 10th person on that list to receive the survey. To sum up, in this video we discussed variables, how to categorize them as categorical or quantitative, and as explanatory or response. We talked about summarizing variables. For categorical variables, we might use the count, the proportion, or the percentage. For quantitative variables, we'll use the mean. We talked about the 4 processes of statistics: data production, displaying and summarizing, probability, and inference. We looked at data production in particular and looked at unbiased methods of sampling and unbiased study designs. We talked about the different types of bias that could be introduced by bad study designs and bad samples. And we talked about the different ways of collecting samples.